is applied to a 10 kg ring as shown if slipping does not occur. Okay, that's key. Determine the ring's initial angular acceleration and acceleration of the center of mass g. Neglect the thickness of the ring. Okay, so one thing we will give you in such a problem is we will give you either the radius of gyration or we'll give you the radius of, well, we'll give you the moment of inertia. So the moment of inertia for a ring is mr squared divided by, no, it's mr squared, my bad, it's mr squared. And this is going to be given. Alternately, we might give you the table which is on the book. Okay, so you do not have to memorize this. Okay, so what's asked? We're asked to find acceleration of g, the angular acceleration of the ring. Yeah, that's about it. Okay, so the key thing here is that you're told that slipping does not occur. Okay, when slipping does not occur, there are a set of equations which you need to develop. But before we develop the equations, let's draw the free body diagram. So force F mg, normal force, oh, this is not right. So this is 30 degrees, this is 45 degrees. Okay, does that look okay? Is it complete? It's not complete. I'm missing the friction force. The friction force always opposes motion. So it's going to be in this direction. Okay, actually the friction force, the direction depends on inertia and mass, and I would recommend assuming it the way I've shown. So it's always opposite to the direction of motion, and if it actually turns out to be the other direction, it actually come out from the math. Okay, so equations of motion. So okay, another thing about a free body diagram is, and I see this mistake happening all the time, is this is a rigid body. It is not a particle. When you have a rigid body, the point of application of the force is important. So do not draw that mg, say over here, or do not draw the force at the center of the ring, because it's important when the force acts. That force creates a moment, and you just cannot assume it to be acting at a random place. Okay, so if it's a particle, when dimensions are not given, like if it's a box and dimensions are not given, you're free to assume the force acts anywhere, because we're not going to invoke the rotational F equals ma in rotational coordinates, right? So for equations of motion for a rigid body, there are only three: F equals ma in the x, F equals ma in the y, and mass equals inertia times acceleration. So let me start with the F equals ma. Okay, so I need to find the net force in the x direction. So F cosine of 45 degrees minus F friction equals mass times acceleration of g. So let me assume that this is I, j. the second equation is Fy equals mass times acceleration of g in the y direction, like gx. So the net force in the y direction is N acting upwards, so it's positive, mg acting downwards, so it's negative, equals the mass times acceleration, that is 0. So N is mg. Oh, did I leave out some force? Good catch. So minus F sine 45 degrees. And it should be positive. I'm glad that you're paying attention. Okay, so those are the two equations. We have the moment equation. Now, when you write a moment equation, we have a choice. We can write moment about any point. You can write moment about G, moment about A, where A is the point of application, about C. You could, in fact, you could choose any point on the ring or outside the ring, doesn't matter. However, you want to judiciously choose the point at which you apply the moment equation, because so as to eliminate as many forces as you can. Okay, so I know F, I know mg, I know n. I do not know ff, right? I do not want to solve for ff. I've not been asked to find ff. So if I choose, for example, g, point g, then ff will show up in the equation, right? If I choose a, again ff will show up in the equation because it's talking about c. So the best place I can apply moment equilibrium is about point c. So apply about c equals mass times acceleration of g. I'm forgetting this. This is I. Is it ig alpha plus rg with respect to c crossed with mag, I think. Right? Is that the formula? What is the formula? Okay, so let's try to simplify that. Moment about c. This point is c. Okay, now the good thing is that ff passes through c, n passes through c, and mg actually passes through c too. So all those forces have no contribution towards the moment about c. The only force which will contribute is F. Okay, so I need to find the moment at C due to force F. What I'll do is I'll resolve force F in the x direction, find the moment due to force F in the x direction, find the moment of F due to in the y direction. So let's find the contribution of F cosine of 45, which is the force in the x direction. Okay, I need to find the distance between this point and C. So this is F cosine 45 degrees. So what's the momentum? It's the vertical height I just showed. Right? It is R plus R sine 30 degrees. So this is R, this is R sine 30 degrees. Okay, so if I hold the ring at C and apply force in the x direction this way, then the ring is going to turn in the clockwise direction. So this is going to be negative. My convention is counterclockwise is positive. Okay, so that's the effect of F cosine 45. Then I have F sine of 45 degrees. Which is this force. Okay, I need to find the distance from this force and the normal distance from point C. So this distance. So this is going to be R. cosine of 45 degrees. Sorry, cosine of 30 degrees. Right, because this is 30. So R cosine of 30 degrees. Okay, so again I need to find the right sign. So again I look at F sine 45 act upwards, hold the ring up at C, and then see what's the effect of pulling the ring by holding it at C. So clearly F sine 45 causes the ring to turn or apply the force in the counterclockwise direction. So that is positive as per my convention. So that's positive. Okay, equals Ig alpha. Ig is m r square. It's given to me. Alpha is the acceleration in the clockwise direction, right? Okay, we can. So we have an option. We can assume either alpha to be counterclockwise, and then the math will tell us that the right sign. Maybe that's the better way to do it. So I'm going to draw alpha this way. Okay, that's not the right alpha, right? You know from experience that if f is applied that way, it will move in the clockwise direction. So we know that's not true, but let's assume it to be in the counterclockwise direction. You could do it the other way too. So it's going to be alpha with a positive sign because counterclockwise is positive. Okay, the final thing left is this particular cross product. So the vector from, so this is the vector from C to G, C to G, so this vector. So you can see that the vector is pointing in the positive J direction and its length is R, right? Crossed with mass times acceleration of G. Now, if I assume that alpha is in the counterclockwise direction, then AG is going to be, okay, let me write AG so I can choose to write, well, let's say assume that AG is in the positive I direction. Okay, AG is this way. So AGI. Okay, so this is sort of not consistent. AG is, I'm showing it to the right, and alpha I'm showing counterclockwise. Okay, I choose alpha that way because that's positive. I choose AG positive because it's, well, AG in the direction I've shown, which is along I, because that's positive. And actually, the math will actually give me the right sign. Is there a question?
If you just decided the direction, just
arbitrarily, yeah,
okay.
Yeah. We will see that it actually come out in the right way. So I'm going to assume it to be that it's in the I direction. And so when you take this cross product, if you remember the trick, I, J, K, so it's going to be mass times AG times R. J cross I, to go from J to I, you need to go in the clockwise direction. So that's going to be minus K. Okay, so what I really care about in this thing, in this case, is it's mr square alpha minus magr. Okay, this equation is sort of abuses notation because it's not technically correct to write a vector and a scalar, but I wrote it down that you can only look at the sign. This is only done to the sign. If you do not like to use this equation, what you need to do is you need to look at mag and the vector r g with respect to c and see the effect of the force mag. What does mag do to the, what is the moment due to mag acting the way I've shown? It's clearly going to move the disk clockwise or apply a force in the clockwise direction. And that's why there's a negative sign, because my convention is counterclockwise positive. So that's another way of thinking of it if you do not like to use the vector product. Okay, so it's a negative sign because clockwise positive is negative. 2. This thing is going to be 3. Okay. So, so far I've written down 3 equations which are numbered. The unknowns are F, what else? Alpha, AG, and N. Okay. So 4 unknowns and 3 equations. So clearly I cannot solve. Okay, now I'm not asked to solve for all the unknowns. I've only been asked to solve for A, G, and alpha. But if you are told to find all those 4 unknowns, right, you cannot solve for the 4 unknowns because you have 3 equations. Now, one mistake which people normally do is they say, well, I can use the moment equation the way I want. I wrote moment about C. Let me generate my 4th equation by writing moment about G or moment about A. That is not right, because the moment equation is one equation. It doesn't matter from where you take the moment. So by writing the moment equation about G and A, you will not generate an extra equation. You can only use the moment equation once, to not use it multiple times. That doesn't add any extra information. Okay, so you are forbidden from using the moment equation more than once. You can use it more than once if you want to sort of eliminate force and so on, but you cannot use it as an additional equation which will help you to solve the problem. So the 4th equation actually comes from kinematics. There's no dynamics. These 3 equations are coming from dynamics, right? There's force equals ma and mass equals I alpha. So the 4th equation is AG.
You can find N from equation 2.
Absolutely, yeah. I agree with you. Yeah, so you have 3 equations, but then you have 3 unknowns and you'll have 2 equations.
Oh.
Right? So yeah, so the math comes out right. So people have pointed out in the past too that N can be solved, but I'm just including that as my unknown, so it won't really solve the problem. Like if you have to get the 3rd, 4th equation, otherwise you cannot solve it. So AG is R alpha. Now there is something which you got to be careful about. The way I've assumed AG is to the right, and alpha is counterclockwise. So for this to be consistent, it should be AG equals minus R alpha, right? Because alpha is this way, AG is this way. Because alpha R is going to give you acceleration that way, you need to turn it up this way.
So this is the typical way that there's no alpha is this way.
Yes, it's absolutely fine if you assume it clockwise. If you assume it clockwise, the changes you'll have to make is AG will be R alpha, and then on top where I wrote this equation, you'll have to put a negative sign, and you'll be good. I'm just trying to make it so that my unknowns are always in the direction which I assume it to be positive. So K is positive, so I took alpha in that direction. Yeah?
Just a quick question, because this is the way I thought to solve it. Shouldn't the 4th equation, shouldn't that be taken from like the slipping or non-slipping condition?
Okay, in this problem, you're told that slipping does not occur. Okay, so there is no slipping. Now, if there was slipping, or you were not told that there's slipping or not slipping, then this is always true. You need to start assuming it is rolling and solve the problem this way. And then I'll actually get to that in a bit. And then there's another thing to check. So this is my 4th equation. So 4 equations and 4 unknowns. Okay, so in fact it turns out that if you use 3 and 4, so 3 is this one, 4 is this one. If you actually sub in the value for AG in equation 3, you should be able to solve for AG and alpha. You do not need equations 1 and 2. Right? Can you see this? If I take AG equals R alpha and sub it in here, right? Then this thing is only going to be a function of alpha. I know M, I know R, and on top F cosine 45 is known, F sine 45, everything is known here. So I can solve for alpha using 2 and 3 and 4, and you should try this out. Let us solve for AG and alpha. AG comes out to be 0.224 meters per second square, and alpha comes out to be negative 0.56. Okay, the negative indicates that my direction assumed was wrong. It has to be in the clockwise direction. You could also solve for FF, which is a friction force, this one, from 1. And what you need to do is to check for rolling. FF, what's the condition on friction force if the ring is rolling? Less than mu static times n. Now in this case you are not given mu static. Okay, so of course you need to be given that in order to check this condition. How would you get n? You get it from 2. Like what John said, n is solved from equation 2. So you got to check that. If you're not given it is rolling, then you got to check this assumption, that is equation 5. If it's not true, then you got to go back and, well, if FF comes out to be greater than mu s, then it's slipping, and then what happens is you get another set of 4 equations. So what I'm going to do is I'm going to add a little bit of this one, make it simple. Rolling, slipping, problems. So it turns out there are only a few types of problems. One is there's a ring or a disk which is subject to moment m. In which case you assume the friction to be this way. There could be of a ring or a disk subject to a force, can be horizontal, vertical, or at an angle. Assume friction force to be this way. And then the third could be there is a ring or a disk which is rolling down an inclined plane, in which case also you assume that friction force is this way. Okay, those are the typical 3 problems that you will see if you see a rolling sliding problem. So first thing you do is assume rolling, set up equations. Fx equals ma gx, Fy is ma gy, and moment about, I'll put a star, I'll tell you why I put a star. G with respect to that point, where star is judiciously it's cross product, judiciously chosen point. So for example, in the previous problem we chose a point star, the star thing, to be point C, because all the other forces, the force which we did not know, FF, was acting at C. So you assume rolling. So this is 3 equations, and then the fourth equation comes from AG equals R alpha fourth equation. Okay, then you check if FF is less than mu Sn. Okay, yes, rolling is right, you stop. No, it is slipping. So then you have to resolve this problem assuming slipping. What you need to do is you will write the same equations and then moment about a judiciously chosen point is Ig alpha plus. So those are your three equations. And then the fourth equation is actually FF is mu k times n. Okay. Note that Ag is not equal to R alpha for slipping. So what you see is that these equations will have only four equations, three from F equals ma. The fourth equation for rolling comes from kinematics, which is Ag equals R alpha. In case of slipping, it comes from the friction condition. Okay, so if you want more practice, then rolling should see homework questions. For a slipping question, there's one question which I did in the notes. In the textbook, there is a problem, and you might want to solve this yourself on page 459. Okay, there's a problem on slipping. So what I can tell you with certainty is that if we do not test you on a rolling slipping problem in this exam, very likely we'll test you in the finals. This is one of the very standard problem which instructors always like to test people on. So it pays. It's worth your time trying to spend your time learning how to solve this. So as I said, there are only three scenarios we can ask you. I can't think of a fourth one. Or it could be a combination, right? We could put, yeah. Yeah, good.
Is there orientation of the direction of the force of friction affect the end result? Because I've seen problems where it's facing the same.
Yeah, it will. Yeah, so the force of friction, the computation depends on. It depends on, I think, the radius of gyration and the inertia and the mass. So the force of friction actually will change direction. So you can start assuming that way, and if the direction is actually opposite, then it comes out from the math. It will give you a negative sign. So you could have these three questions, or it could be a combination. Like for example, I could put a problem where there is friction, where there is force F as well as moment, which is very.
Last year, we had like a cable attached to the school, and that cable was pulled to the wall.
Okay.
The wheel, the school was being pushed away from that wall. So it was rolling, but like friction was directed in the same direction it was rolling. It was forced to slip.
Right.
I think
Yeah.
I remember reading something about like Wittgen's also like where you apply a force, like you're pulling a wheel or something like that, instead of like rolling it from the center, that changes the friction direction.
Yeah, friction direction depends on, well, if it's sliding friction, it always opposes motion, always. Now for rolling, that's not true. Rolling, the friction can be in the same direction or the opposite direction. So I would just start assuming in one direction, and then the math will tell you. So it is not okay. So it's okay to assume friction the way you want till A. If you see till this point, if you think that it is slipping, this comes out, then you cannot assume this friction to be acting in the direction which is in the direction of motion. That's wrong. Friction force always opposes motion. Okay, is that clear? Yeah.
Can you go over how you got the alpha R was negative?
Yeah, sure. So I assumed alpha to be counterclockwise. I assume AG to be to the right. Now, for it to be consistent, right? If you just look at this thing with the cylinder turning with alpha, which is counterclockwise this way, then AG would have been in this direction, right? But my assumed direction for AG was this way. So to make it consistent, I need to put a negative sign. Okay, next question. So two blocks A and B have mass 5 kgs and 10 kgs. We put it on the figure 5 kg, 10 kg. If the pulley can be treated as a disc of 3 kilograms, so 3 kilograms and radius 0.15, find the acceleration of block A. So acceleration of block A is unknown. Neglect the mass of the cord and any slipping on the pulley. Okay, so a problem like this, you'll also be given the inertia of a disk. Inertia of a disk is mr squared divided by 2. Okay? You do not have to know that. Okay, so let's think of the problem before we solve it. If there's a 10 kg mass to the right, attached to a 5 kg mass, and if you let this go, well, this will also be given. It's not given, unfortunately, that there's gravity. Otherwise, this thing will not move. So clearly, B would move down and A would move up, right? Because the disk has mass and inertia, it is going to have an angular acceleration too. Okay, so if I make the mass of the pulley equal to 0, it's a problem on particles. This is a problem in chapter 17. But if I make the mass of the pulley go to 0, then it's a problem in particles, chapter 13, because there's going to be no inertia if the disk has 0 inertia, right? So you could figure either way. Now, because of the inertia, let's first draw the free body diagram and then it'll get clear. So, free body diagram. Okay, so you can draw multiple free body diagrams. You could draw a free body diagram of B. You could draw a free body diagram of A. You could draw a free body diagram of A and B together as one system. Okay, so FBD. Okay, now the tensions will not be the same. Okay, the tensions are the same if the pulley was massless. If the pulley it has a mass, then the tensions will not be the same, because the net tension is causing the pulley to turn. And then you can of course draw a free body diagram of this. This is going to be TA plus TB. And of course there is mg. So these are, well, 3 sets of 3 free body diagrams you can draw for the individual systems. Now, in this case, you're not told to find the tension A, nor are you told to find the tension B. So why am I even spending my time and effort trying to find TA and TB? Let me just try to eliminate TA and TB. And one way to eliminate TA and TB is to not draw a free body diagram where you have TA and TB. So if you draw this free body diagram, which is the combined system. You can eliminate the tensions coming up here because now I've not cut the string here. However, there would be the tension showing up here, right? So this is a free body diagram of the entire system. Okay, so I thought I could eliminate TA and TB, but by drawing that free body diagram, I'm still not able to eliminate the tension because it still acts at O. There is a weight of the pulley. All right. Mg. If it's massless, TA equals TB. If the pulley is massless, yes. Okay, so, well, what do I do? How do I solve for the acceleration of A? Okay, so when you see a problem with, so this is, first of all, this is a problem on rigid bodies because there's inertia. So there are three equations you can use: F equals ma in the x, in the y, and if you use F equals, so clearly the motion of interest is in the y direction. So F equals ma in the x doesn't make sense. So F equals ma in the y direction. If I use that on this particular problem, then I'll have a TA and TB showing up in the equation because there's a force in the y direction. However, if I use the moment equation judiciously, then I may be able to eliminate TA and TB, right? I can take moment about any point I want. Now, if I take moment about a particular point, I can eliminate TA and TB. What is that point? Oh, if I take moment about O, then I eliminate essentially TA and TB. So moment about O is I O alpha okay, where IO is the inertia of the entire system. Okay, so the moment about O is mb times g, okay, acting downwards, times the radius of the disk. Okay, so if I hold the pulley at O and apply mbg downwards, then that's going to apply a clockwise moment, so that's going to be negative as per my convention. And then if I do the same thing with MAG, it's going to apply a moment in the clockwise direction, this way, right? About out, this way. So okay, then the inertia of O. Okay, this is going to be the inertia of the disk. Okay, is that it? Times alpha. Is that it? Yeah, I need to include the inertia. So I can either include it, the inertias of the due to MA and MB in that equation, or I can write the effect of acceleration of A and G. So let me choose the latter way, which is MAA is the acceleration times R, because this MA is acted upon by through a distance R, and then there's going to be MBA R. I need to choose a sign. So hold on. AA. Let me write it in a better way. Okay. Equals. Okay, AA is acceleration of A. Now, what's the acceleration of B? is the same as that of A, right? Because it's just the same string which goes over. Okay, so AA is downwards on the right, so equals half mr square alpha. Okay, and I need to write the mb times AA. Sorry, mb times AA is the force due to the acceleration, or the moment due to the acceleration is going to be the force times r. And the question is, what's the sign on that particular moment? It's going to turn the disk in the clockwise direction, so it's going to be negative.
That's from the vector equation?
You can write it from the vector equation too. One way is you could write the vector equation. Other way you can do it is to just think of it in terms of moment, just like we think of moments MA and MG. So MBAA, acceleration of A times R is going to be clockwise. M capital A capital A, which is the moment due to this force, is going to act, well, it's going upwards, so it's going to also give a clockwise moment, so it's going to negative.
So these are moments that you're thinking?
You can think of them as moments. So remember, if you go back,
So
you
right
can,
on the left side then of the equation?
No, this is from that vector equation.
you could also get it from the vector equation. In this case, it's going to be point, let's call this point A, call this point B. In this case, you can get this. This can also come from R, O, A cross with M, A, and R, B with respect to A, sorry, B with respect to, so it's G with respect to, yeah, so it's going to be O with respect to B, crossed with M, B, something physical. So this will come from R, this is B crossed with M, A, M, B, A, and this will be R, O with respect to A crossed with M, A. Yeah, you could write it this way too. But what that equation is basically telling you is that it's a vector from O to B, for example. So O to B is a vector which goes this way, right? And MBA is this way. So when you take the cross product, it's going to be MA times MB times MBA times R. It's going to be in that direction. So it's going to be negative. This is R I. This is MB AA J in the negative direction. Right? This is in the I direction, this vector, and then this is going to be in the negative J direction. So I cross J is K, so it's going to be minus K, which means that this is going to be negative as shown here. Similarly, this is going to be negative. They're both negative, right? So there are two ways to do it. One is use the vector equation, like I've shown you over here. Or you can just use the fact that you can think of MBA as a force acting downwards. You find the effect of that force multiplied by the distance to give the moment. So think of MBA as a force. We'll also do the same trick. It will basically is the same effect as computing this. Whatever you like. If you like to write vectors, go for it.
It will be on the horizontal radius.
It will be the horizontal radius. Okay, so the only thing left is, if you look at this equation now, it has two unknowns. A and alpha are unknowns, two unknowns. But I've written only one equation. So I cannot solve for A and alpha unless I generate a second equation. So the second equation comes from kinematics, right? So AA is equal to alpha times R, and I need to figure out the right sign. So AA is, so my convention is alpha is counterclockwise. And the reason why it's counterclockwise, because look at how I wrote this equation. I wrote it as if alpha is positive in the clockwise direction, counterclockwise direction, right? Because that moment is what? It's positive. It can only be positive if alpha is acting in the counterclockwise direction. However, AA is assumed to be downwards, which means that what's the right sign on over here? It's negative. So this is my second equation. So now I have two unknowns and two equations. So I can solve for AA and alpha using the two equations. And let me write this equation. This is 1. This is 2. 1. Any questions on this?
Is this like basically what why the MB times alpha AR
MB times alpha AR negative. You're saying this one? This one?
Yeah.
Okay, so MB AA is this way, right? And then R is this about O. So it's going to produce a clockwise.
Right, it's a moment, right?
It's a moment, yeah.
So should it be on the left side?
It should be.
And then when you bring it over, it's going to be
No. So there's a difference. The moments due to external forces are on the left side, and the moments due to inertial forces are MA, I alpha is on the right side. So when you have things on the right side, you need to treat them as they are on the right side. Do not do the mistake of treating MBA as an external force. It's a different thing. Yeah, so what I'll do on Friday is, by the way, I'm going to be there on Friday, unlike previous to Friday. So what we'll do on Friday is, I'm planning to have like short questions and maybe one long question, and we're going to use iClickers, and I'm not going to count this towards your quiz grade. The hope is that way I'll sort of simulate the exam, so we'll probably have like 2 or 3 short answer questions and 1 long answer question, and I'll stop, you solve it, and then I'll probably try to go around and help you out. So please solve the questions which we have posted in examination conditions so that you can maximize your score. It's the exam, we've already set it. It's the same format as your second exam. There are 5 short answer questions for 50 points, and then there are 2 long answer questions for 60 points. You can earn 110 points.